All right, I tried making a video and uploading it to YouTube and it wouldn't let me, so I'm recording straight to YouTube right now. Hopefully this works. I've been doing this all morning and hopefully this one actually comes through. What we're doing right now is we're doing Chapter 2, Lesson 1, which has to do with ecosystems and biomes. The whole chapter is ecosystems and biomes, and the lesson is energy flow in ecosystems. I think it's important that we quick go over some of the key terms because there was some confusion in the assignments that were submitted to me, and I want to make sure everybody's on the same page. So we're going to go through this really quickly. First, these are some terms I know that you know, but we're going to go through them again. A means without, bio means life. So abiotic is all the non-living parts of an organism's habitat, and biotic is all of the living parts of an organism's habitat. Habitat itself is the environment that the organism lives, grows, and reproduces in. And it has to have all the necessities for that to happen. An ecosystem is a community of organisms that live together, particularly in a particular area, and then they include also all of the biotic and abiotic factors in that area make up the ecosystem. In an ecosystem, there are energy roles that happen. The start of the ecosystem is the producer, and a producer is an organism that makes its own food. They're also called autotrophs. What they do, typically it's a plant. There are some bacteria that use chemicals, and they're called chemotrophs to create their own food, but primarily we're going to talk about plants. A plant is the base of many food chains. The plants take the light energy from the sun, convert that light energy into chemical energy, and release oxygen through photosynthesis. The bacteria that I'm talking about is just a small amount of the whole overview of producers, and they take hydrogen sulfide from their atmosphere and make it into food. But those are found like way down deep in the ocean. Consumers are organisms that cannot make their own food. They must get their energy from the food that they eat. There's different categories of consumers. There are herbivores, carnivores, omnivores, and scavengers. Herbivores only eat plants. They are the primary or the first consumer. They get their energy directly from eating plants. Carnivores only eat animals. We used to think of them as meat eaters, but this also includes insects and worms and things that you don't typically think of as meat. Omnivores eat both plants and animals. And scavengers, those eat like dead animals that are laying around. The dead animals are called carrion. If you've seen roadkill, the birds that stop and eat that roadkill are scavengers, along with possums and different things like that. Here's a food chain. We asked you to make a food chain, and I got a lot of lists. I got lists of producers, consumers, and decomposers, but I did not actually get very many food chains. A food chain has the arrows in it, and it shows the way that the energy is flowing through the chain, starting with the grass being the bottom, the original source of energy after the sun, but the original source of consumable energy. The grasshopper eats the producers, and then the arrow shows the transfer of energy from the grass to the grasshopper. The frog eats the grasshopper, and again the arrow shows the transfer of energy from the grasshopper to the frog. Producer is the grass, then primary, secondary, tertiary, and quaternary as they go up the food chain. Decomposers fall into all parts of the ecosystems. They can be in the producers, they can be consumers, first consumer level, secondary, tertiary, it does not matter. Anytime something dies, a decomposer, which is primarily fungus, mushrooms, and bacteria, will break down those dead things, turn them into their original elements that they're made up of. All living things are made up of carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur in varying degrees. When something dies, a decomposer breaks those dead organisms down into their original elements. And that's the purpose of a decomposer. But depending on what level it is, depends on how much energy they get from that breakdown. Here's a food web. This food web shows you can see corn to grasshoppers. You follow the flow of the energy. All a food web is multiple chains together that all live in the same area. I got many food webs that were not necessarily all in the same area. I may have gotten some that had the savanna from Africa mixed with the rainforest. They still were two food chains, but they weren't two food chains that interact. And that's what makes a food web. Those they have to live in the same area and they have to interact with one another. So if you look here, the one food chain would be corn to grasshopper to frog to python to eagle, and another would be corn to grasshopper to rat to either wolf and then to eagle or directly to eagle. Those are three different chains that all exist in this section of the food web, and here's the rest of them. So what you're going to do now with that information along with what you gathered from reading is you're going to look at page 77 and you're going to answer questions 1 through 5. You're going to take a picture of it and then you're going to submit that picture like you've done in the past. If you have any questions, you need to email me, or if you have Mr. Justek as a teacher, you need to email him so we can clarify all of the questions you may have. So we'll talk with you soon. Bye.